Okay, this is a continuation of the lesson on Tuesday, 16th of June. Okay, we're looking at this question 2b on page 9 of your booklet, and the question says that we have to prove that triangle XWZ is congruent to triangle XYZ. Okay, and we're also given a few pieces of information that XW equals XY, and we're also given that XZ is perpendicular to WY. So let's start off by stating the triangles that we're working in. So we can say in triangle XWZ and triangle XYZ, we know that WX is equal to YX, and that was given. We also know that we've got right angles here. So we also know that angle WZX is equal to angle YZX, which equals 90 degrees. And the reason for that is that we were given that XZ is perpendicular to WY. Now we still need one more piece of information, and what we have here is a common side here. So I'm going to put a double dash on that side. So we can say that XZ equals XZ, or you can just say XZ is a common side. And I've got that XZ equals XZ common side. So let's look at what we've marked out. We do have right angles. We do have the hypotenuse and another side. So therefore triangle XWZ is congruent to, now we went XWZ. So we went down the side with one dash and the side with no dashes, and the corresponding way of naming this triangle is XWZ is congruent to XYZ. And the reason for that is RHS. Okay, we're now on page 10 of the booklet. We've got another 4 examples here to go, and then I will set you some homework for tonight. Now, we are told that ABCD is a rectangle, and you have to prove that triangle ABD is congruent to triangle CDB. So, of course, our first step is to state the triangles that we're working in. You can actually pause the video and attempt this on your own, as well as the next few questions, and then restart the video when you're done and check your answers. So we've got in triangle ABD and triangle CDB, I'm just going to write it out the way that it was given in the question. We know that AD is equal to BC for a start. Reason, opposite sides of rectangle are equal. Okay, now because you've been told that ABCD is a rectangle, you're allowed to use any property of a rectangle. And I don't want to see you just write property of rectangle. I need to see what the actual property is, and its opposite sides of rectangle are equal. We also know that BD, remember we're trying to prove that these two triangles are congruent here. We know that BD equals BD, common side. Okay, and I can just write common. Actually, you might need a bit more room there. Common side, okay? And the other thing that we know is that angle DAB is equal to angle DCB. So, sorry, DAB, I'm going to go BCD is equal to angle BCD. That's a B there. I'll just fix that up. So I've just fixed that up, equals angle BCD, which is 90 degrees. Reason, angles in a rectangle. Just running out of room there, so I'll just move that over. That the angles in a rectangle are 90 degrees. Okay, so what we've got here, I've just marked in red everything we've got. So therefore triangle ABD, so I've gone along the long side and then the hypotenuse, so I need to do the same here. So going along the long side and the hypotenuse, or in terms of angles, I'm going from this angle here to that. So we're starting with the right angle and going along the long side. So ABD is congruent to triangle CDB, and the reason for that, we've got right angle, we've got hypotenuse, and we've got another side, which is RHS. Okay, now for the second question. Okay, in this question, we have to prove that triangle UYV is congruent to triangle XYW. Okay, so we first start off by saying in triangle UYV and triangle XYW, what do we have? We know that UY equals XY, and that's given because it's marked on the diagram. Okay. We also know that angle VUY is equal to angle WXY, so WXY, which equals 30 degrees, and that was also given because the 30 degrees are actually marked on the diagram. We also know that angle UYV, now I'm coming along the side with the single dash and along the blank side, so I'll do the same here. That's equal to angle XYW, and the reason for that is that they are, when two lines cross, you end up with vertically opposite angles, so they are vertically opposite angles. Okay, notice I've used the symbol for angles, which you're allowed to use. And so therefore we can say that triangle UYV, so I've gone along this, I've gone from the 30-degree angle to the arc to the blank, so I need to do the same here. So that's congruent to triangle 30 arc blank, so it's congruent to triangle XYW. And the reason for that is we've got one angle, two angles, and another side. Notice that that side is positioned between the two angles in the left-hand triangle, and that side is also positioned between the two angles in the right-angle triangle, so it's AAS. Now for question 3. Now there's a little mistake, typing error just over here. We've got ABCD is a square. Now because we're told that we can use any property of a square that we want to, such as all angles are right angles, that all four sides are equal or opposite sides are equal. Okay. We're also told that E is the midpoint of AB, and we have to prove that triangle AED is congruent to triangle BEC. So we have to prove that this triangle here, AED, is congruent to triangle BCE. So let's start by identifying the triangles. So in triangle AED and triangle BEC, what do we have? We know that AD is equal to BC, and the reason for that, it's not given. It's because all sides of a square are equal, or you can just say sides of square are equal, or equal sides of square. Okay, we know that AE is equal to BE, and the reason for that is that we were told that E is the midpoint of AB. So if E is the midpoint of AB, it divides it in half. That's what a midpoint does. So we say that AE equals BE. Notice I'm saying BE because I'm going from the right angle to that midpoint, and here from the right angle to the midpoint, and the reason for that is that E is the midpoint of AB. Now you do not say that it's given. It was not given because there are no markings on the diagram. The reason you know that is that E is the midpoint of AB, and that is the only reason you know it. So if you put given, you're going to lose a mark for that. Okay? Now we need one other piece of information. We've got two pieces of information. We also know that angle DAE is equal to angle CBE, which equals 90 degrees. I know it's marked on the diagram, but you can write that angles in a square are 90 degrees. Okay? So therefore we've got enough information. Therefore triangle A, sorry, I just got to fix that up. So it's triangle AED, just a little mistake there. So triangle AED is congruent. So we've gone right angle up to this corner here and then to that midpoint. So we haven't. We've gone AED. So we're going along that shorter side and then the hypotenuse, or the double dash side and the hypotenuse. So it's congruent to BEC. So triangle BEC. Now this is not RHS just because it's got a right angle. It is two sides and the included angle that are equal. Okay, so the reason that they are congruent is SAS. Okay, now for our last question. We are told that ABCD is a parallelogram, and you have to prove that triangle ABC is congruent to triangle CDA. Now, because you're told that ABCD is a parallelogram, you're allowed to use any property of a parallelogram that you know. And those properties will include opposite sides are equal, opposite sides are parallel, okay? So we can actually do this question a number of ways. We don't have to just do it this way. This is one way of doing it. So we'll start with this. So we can say in triangle ABC and triangle CDA, we'll just write it down the way that it's given in the question. We know that AC equals AC. So we're trying to prove that this triangle ABC is congruent to CDA. So AC equals AC because it's a common side. Okay. We also know that AB equals DC. Reason, they are opposite sides of parallelogram which are equal. So opposite sides of parallelogram is fine. Okay, I'll put equal. We also know, sorry, there's a little mistake in this one as well. I'll just fix that up. So we also know that AD in this triangle, I'm going to do that with a triple dash, equals BC in this bottom triangle. So AD equals, I'll put CB to get it in the right order. Again, because it's the same reason as the reason in the line above, you can just say similarly. In other words, its opposite sides of parallelogram are equal. But I can only say that because it was written directly in the line above, okay? Or if you want, you just write opposite sides of parallelogram are equal again. So therefore, triangle ABC, now I've gone along the double dash side to the triple dash side. To name that in corresponding order, that would be along the double dash and the triple dash side. So it's congruent to triangle CDA, and the reason is SSS. Now this question could have been done another way. I could have said that I've got parallel lines. Actually, I'm going to do this question again on a piece of paper, and I'll just show you another way of doing it. Okay, so I'm going to do this question again. So I'm going to draw my parallelogram, which is A, B, C, D. And I'm going to put in this diagonal. And again, I'm going to, we know that ABCD is a parallelogram. So I'm going to put in the parallel sides actually this time. And I want to prove that triangle ABC is congruent to triangle CDA. So this is my second method, okay? So I'm going to start off with in triangle ABC and triangle CDA. I'm going to say that for example, that this angle here, that angle DAC is equal to angle BCA. Reason, alternate angles, AD is parallel to BC, opposite sides of parallelogram. That's why AD is parallel to BC, because opposite sides of the parallelogram are parallel, okay? So I've got that marked in there. I could also use other properties of a parallelogram if I want. I could say, for example, that this angle here, D, equals angle B. So remember, we're doing, actually girls, you know what I've done wrong here? I've put these on the wrong side. See how I've said in triangle ABC and triangle CDA, I've actually got the information about the first triangle on the right and the other triangle on the left. So I should swap them around, okay? So I should say that angle BCA is equal to angle, so I went BCA is equal to angle DAC. That's for the first one. Now I could also, for the second bit of information, I can say, well, angle ABC is equal to angle CDA, and another reason here I can put is that opposite angles So opposite angles of parallelogram are equal. Okay, now I could have also done alternate angles this way and said that this angle down here at C is equal to this angle up there. But I was just trying to show another property of a parallelogram. So there's actually about 4 different ways you can do this. So I've got 2 angles. I really need to find another side. I mean, I can do common side here. I can do the opposite sides of the parallelogram are equal. I can do these sides are equal. I might just do common side. So I've got that AC equals AC and that it's a common side. Okay, whoops. I'm running off the paper there, sorry about that. So AC equals AC, common side. Just focusing that back up. And so therefore triangle ABC is congruent to triangle CDA. Now just making sure they're in order. ABC is blank dot arc, CDA is blank dot arc. Sorry, CDA is blank dot arc. And therefore we can say we've got 2 angles and another side, so that one's AAS. Remember, AAS does not have to be in any particular order. Okay, I definitely did not want to do AAA. That is not a test for congruence. Okay, and as I said before, I could have said that side AD was equal to BC, opposite sides of parallelogram. I could have said that AB equals side DC, again, opposite sides of parallelogram are equal. So there are many different ways that I could do that question there. There's probably, I can think of about 4 or 5 different ways of doing that question. I've just shown you 2 ways there. Okay, now I'll just set the homework for tonight. Okay, for homework, you can go to exercise 10.8 in the textbook. We've already done question 1 as one of our examples, and also question 2. Sorry, I'll just move this down. So we've done all these examples already. Okay, we've also done question 1, A and B. We've also done question 2. So for homework, if you could do, I'm thinking question 3. I'm just having a look at what these questions are. How about question 3, A, B, C, D, E, F? Okay. There's a fair few questions actually in the exercise. We may not do all of those. Actually, I'll change my mind. We might do questions... I'll just work it out and then I'll write it down. Actually, once again, changed my mind. You can do question 3, A, B, C, D, E, F. So, and if you could also just try question 4, A, B, C. Now we will continue with question 4 tomorrow. So please definitely try and do all of question 3. Just noting here that this is a circle, say in question F, and that OE is equal to OF, which is equal to OG, and which is equal to OH. And the reason for that is that they are equal radii of circle. Okay? And also with question 3E here, that OL and ON are also equal radii of circle. So when you're trying to say that OL equals ON, you just put OL equals ON, and in brackets you would write equal radii of circle. So please, if you can do question 3, A, B, C, D, E, F, and then also try question 4, A, B, C. We will continue with the rest of with some bits of question 4 tomorrow. And we'll also try and start the next exercise, which is exercise 10.9 tomorrow. Okay, but I'll just close that and put this up. So your homework, I'll just fix that. And so your homework for today is from the Year 9 textbook, exercise 10.8, question 3, A to F, and questions 4, A, B, C. So that, I think, is 9 questions for you to do. They shouldn't take you very long, okay? But you'll still have to copy this video out as well.